What's up guys, Matty here. Sometimes in our data streaming applications we want to run time-based aggregations. For this, Kafka Streams provides a tool called time windows. These windows allows us to create all sorts of time-based aggregations and joins. In today's episode, we're going to learn everything there is to know about time windows, and we're going to be modifying our bank application to add new time-based aggregations and validations. So welcome to Programming with Matthew. Time windows in Kafka Streams. We use time windows in Kafka to produce time-based aggregations. For example, we want to know how many times a user tried to log into an application in 5 seconds. We could say that if in 5 seconds the user has failed to log in more than 3 times, then we want to block their account for 1 minute because we suspect that it's not the user who's trying to log in, but someone else who's trying to get into their account. So in order to do that, we need to do a time-based aggregation. In this case, it's the amount of time the user tried to log in a specific time window of 5 seconds. Kafka Streams brings a lot of time windows operations inbuilt that will help us produce this kind of time-based aggregations. But first, we need to discuss a few things about time. In Kafka Streams, we can talk about 3 kinds of time semantics: event time, ingestion time, and processing time. And then we have to speak about timestamp extractor, which is an interface that Kafka Streams provides for us to extract the timestamp from the events. First, we'll discuss event time. Event time is the time in which the event was created in the producer application. Generally, this is a timestamp added in as part of the payload in the event. For example, a transaction date or timestamp. Kafka Producer API can add the creation timestamp automatically via configuration, and the timestamp extractor will extract the timestamp directly from the payload. Then we have ingestion time. Ingestion time is the time in which the event was appended to the Kafka topic. This is always after the event time because it's after the event was created. Kafka can add this automatically as well via configuration on the topic, and the timestamp extractor will extract the timestamp directly from the payload as well. And finally, we have the processing time, and this is the time in which Kafka Streams is processing the event. This time is always after both event time and ingestion time. And the most simple implementation is a timestamp extractor that will return the current time of the Kafka Streams application. Okay, now that time semantics are out of the way, we can focus on the type of windows that Kafka Streams supports. We first have the Tumbling Windows, we have Hopping Windows, Session Windows, and Sliding Join Windows. The first one we're going to see are the tumbling windows. You could say these are the simplest to understand because they have a fixed duration and they do not overlap. So you basically define a duration for the window, and then every window starts when the other ends. In this case, we have a window of size 5, and all the events that fall into the first 5 seconds belong to that window. And then this second window has only 1 event, and this third window has 4 events. Then we have hopping windows, which have also a fixed duration, but they may overlap depending on the advanced interval that you define. For example, in this case, we have defined a window size of 5, and we have defined an advanced interval of 4. So when we are at 4 seconds from the last window, we are going to create a new one, and these two will overlap. And because they overlap, all the events that fall into the intersection of the windows will be present in both windows. So you have to take that into account when you develop your application. Sometimes this is the desired effect, sometimes it isn't. Then we have session windows, and these ones, instead of having a fixed size, they have a fixed inactivity period. We have to define an inactivity period. So for every new event, if the time difference between the new event and the last one is greater than the inactivity period, then a new window is created. For example, these 4 events here are very close to each other, but this one here is more than 5 seconds away from the last one. That means this creates a new window, and all the events that come afterwards will be in this window unless they are 5 seconds away from the last one. In that case, we will create yet another window. And finally, we have sliding join windows. These are windows that are used to join streams based on time. Basically, you join 2 events if the time difference between them is less than the time gap defined. For example, if we define a time gap of 5 seconds, and here we have less than 5 seconds, so we join these 2, but these 2 events are more than 5 seconds apart from each other, so in that case they are not joined. So what are we going to do? In our tutorial, we're going to modify our bank balance application by adding a time validation. If a user has more than 10 rejected transactions in less than 20 seconds, we want to create an event for a possible fraud alert. This event will use event time, so we're going to implement our timestamp structure and get the transaction time from our existing payload. And finally, because we care about a fixed size time window, we're going to be using tumbling windows. So we're using a 20-second tumbling window. And this is what our application topology will look like. We have the existing topology, which would be above here, but after that we have a rejected transactions stream, and we're going to group by key, because every time we want to do an aggregation we have to do a group by, and windowing is used to do an aggregation as well. So we do a window by, and in here we are going to create a tumbling window of 20 seconds. Then we're going to count all the rejected transactions for this window, and we had to add a suppress step to suppress all intermediate counts, because we only care about the final count of the window when the window closes. Then we turn this into a stream so that we can emit all the events of window closing with the count for each window. And then we have to do a map to transform the key, because the key has also window elements, like the time of start and end for this window. But we don't care about that. Then we're going to filter all the times in which the count is greater than 10. And with all the events that have a count greater than 10, we're going to be mapping them into a possible fraud alert, and we're going to stream them into the possible fraud alert topic. Before we move on to the coding part, let me remind you that all the code will be available in GitHub, and the repository link will be in the description. Make sure that you switch to the branch Windows. And if you like these videos, smash the like button, leave a comment and subscribe. It really helps me when you do that. Alright, so if you have downloaded the code, then you must be looking at this. Make sure that you are in the Windows branch, but you should be looking at something like this. And what we're going to do now is we're going to start building the new part of the topology for a window operation. What we want to do, remember, is to get a count of all the rejected transactions that the user had in 20 seconds. So let's take a look at our topology, and we said we started with group by, so we have to group by key. This will basically group all the events, meaning the rejected transactions, by the key, and the key that we were using was always the bank balance ID. Now that we have the events grouped by a key, we can add the window operation. So window by, and we can basically add a new time window, and this is how we create tumbling windows. We basically say time windows off, and we send the duration. Remember, this is a fixed duration, so duration of seconds, and we wanted to have 20 seconds, so let's go with 20. And that's it, we created our time window, and now we can count the events. So there we count the events, And now there is a step that we said in our topology that we needed to do is the suppress. So why do we do this suppress? And here we have a method called suppress. The suppression of events is because we don't want the intermediary steps. We only are interested in the final event when the window closed. So when the window closes, we are going to emit only one event with the count for all the window. There are different ways in Kafka Streams to suppress events. We are basically going to suppress until window closes. The other way to suppress is instead of until window closes is until time limit. So you have to define a time limit for more events, and you have to define a buffering. But we don't care about this at this time. So we're going to use until window closes. And in here, we have to send something called the strict buffer config. So what is that, you may ask? So this is basically how are we going to keep the events until the window closes. And we can keep them in memory, and what is going to happen is that these events are going to start taking up memory from the Java application. So depending on how much time you are configuring the window, this can grow a lot. And that's why you have different ways to configure this. But because we are not using such a big window and we don't have that much data, we're going to be using this configuration called suppressed buffer config unbounded. So no limits. We want to keep all the events from being sent until the window closes. Then after suppressing, we have to stream this so that we can emit the events as a stream. And now it's a good time to use the peek operation. We want to take a peek of what's going on here. So let's say key value, and we can basically log info and say something like peek rejected transactions count. And let's see, let's say 4. No, let's say rejected transactions for balance ID, and the balance ID we're going to send here count, and we're going to send the value, the key dot key, because this is a window key, and we're going to send the value, which is the count. So now we're going to be printing this information. The reason we're doing this is because we want to see all the events that we are not going to be sending to the topic, because we are going to be filtering them. So now we want to map, and we are going to be transforming the key into a key value. We're going to be transforming the key into the regular key that we had, which was the balance ID, and the value is going to be the value. Now we're going to filter, and for filtering, what we are going to do is we're going to, so we said that we want to filter those that are greater than 10. So value is greater or equal to 10, and then we're going to create a possible fraud alert. So map values to transform the long into a possible fraud alert. And this is something that I created. So this class is here. It has a balance ID, the rejected transaction counts, and a message. So we can basically say key value, and we can say something like this. We have a possible fraud alert, key value, and the message. It's going to be account X has Y rejected transactions, and we format it. Finally, we have to stream this. into a topic that we are going to be calling possible fraud alerts, and we are going to produce this with, and we have the certus long, which is implemented for us by default, and then we have a JSON server, which I have conveniently added here, so we can copy it and use it here, and that's it. And also we need to add this, which I removed accidentally, which is a rejected transactions. We want to stream them into the rejected transactions topic as we used to do in our previous tutorials. So this is all good, but there is something that we are missing, which is the timestamp structure. So we're going to see how to implement that right now. So when we consume events, we have to tell Kafka Streams how is it going to obtain the timestamp structure. So we're going to use here with timestamp structure, and we have to tell Kafka Streams which timestamp structure. So we have to implement this class. So luckily I have already implemented this, and I'm going to basically show you what it is because it's a very basic implementation. I created this transaction time structure, which implements timestamp structure. We have to implement this method called extract, and this method has to return a long, and this long is the epoch in milliseconds. So in our bank transaction object, which we have in the value of the record, we have a getTime method because we have a time property here, and this time is actually the datetime in which the transaction happened. So from here we can transform it into instant and then transform it into epoch milliseconds. And if for some reason this time is null, we are returning the partition time. So here we have to use new transaction time structure, and that's it. So now Kafka knows how to extract the timestamp and add this timestamp to every record that is consumed from Kafka. Another change that was made into this project was in the create topics. I have added the possible fraud alert topic here. So this has to match with what we have added here in our topology. And oh wow, it wasn't matching, so good that we checked. So now it matches, and now what we want to do is we want to start running the application. So for that we have our Docker Compose, and I guess that you're already familiar with this if you have been following all the tutorials. I have already running all my services, Zookeeper, Kafka. A good thing to add before we run our application is a grace period for our time window. This will ensure that events that are delayed because of the network or what have you will be taken into account into the window that is corresponding to them. So we have to let's say a duration of seconds too, in this case. I think a period of 2 seconds would be good. So now we can run our application. So let's go to our console consumer first. We want to start this one. Let's go to Docker and let's create a terminal. Copy this script. And we have our console consumer ready to consume fraud alerts. Now we want to start our application, which is the bank balance application. So let's start it. You can always start it from here as well. Okay, our application is ready. And now we want to start our bank transaction producer. The bank transaction producer is going to be emitting transactions every 2 seconds. So we are expecting our window to be having 10 messages. So we have to wait for 20 seconds now. until the window fulfills the time and closes, and then we'll start seeing messages here. Let's wait a bit more, and we should have, yeah, we have more messages now. So now what I'm going to do is I'm going to stop the bank transaction producer, and I'm going to be modifying the time. So let's say we are sending now one every 1 second. One transaction, one rejected transaction every 1 second. Okay, so now we can start the bank transaction producer, which is going to produce one rejected transaction every second. Okay, it's starting to create rejected transactions. And in 20 seconds, we should see 20 rejected transactions this time. Let's just wait a bit more. Okay, so now we have 20 rejected transactions. Now what we can try is again stopping the bank transaction producer, but in this case we are going to have the transactions every 5 seconds, and because it's every 5 seconds we're going to have 8 transactions in 20 seconds, and it's going to be less than 10, so we shouldn't be seeing any messages coming on the queue now. We might see some messages because of the ones that were in the previous windows, but after that we shouldn't be seeing any other message. So I'll start the transaction producer now. So now it should be, yeah, every 5 seconds it's going to send a new transaction. So if we look at the log of the application, we see less transactions now. It's actually going to be 4, I guess, because 5 times 4 is 20. So yeah, we're going to see 4. But in our topic, we don't see anything. We have to stop seeing transactions. So let's see, let's wait 20 seconds. Okay, so here we see the log with 4, but in here we don't see any new messages. So mission accomplished. We have filtered those messages that have less than 10, and yeah, so everything works. Alright guys, it was all for today, and as always, if you like this video, please subscribe to the channel, leave a comment, and smash the like button. It really helps me when you do that, and I'll be waiting for you in the next episode of Programming with Matty. Bye!